Alright, so back at it. I done fucked up, man. That's why I'm new to this shit, bro. I'm new to this shit. Now I gotta explain to y'all what's going on. Again, I already did it. Did a whole hour video explaining this whole code, and it was fucking stuck on this screen right here. That's all it showed the whole video. That's that's just tragic. It hurt my soul. So let's get into it. I ain't gonna take too long. Actually, we're just gonna go over basically, honestly, the most important things. Like here, we're making a socket. If you know what a socket is, we use these for the internet to connect to things, to allow to communicate with servers, devices. Allows you basically just to send information with them. So basically, we created the socket. Right here, you see socket function. This is IPv4, as you see. Sock stream is TCP, so it takes two arguments. It takes the family, which is IPv4, and then the protocol, TCP, and then this is a successful terminator, meaning basically, but it just add zero, okay, basically. And then we store it in a variable called sock. And then if you're very familiar with like have a high level programming or just like anything other than C language or lower languages, this right here, this pointer allows us to grab the memory in here, okay? So if I was to do this memory is different from this memory. So when I call this variable, it will go use this memory, but it won't use this memory basically. So but that's why I use the pointer here, because I want it to point, I want this to point to this memory instead of if I call it here, like if I do print basically like this, print sock is gonna print an integer because sock is an integer. But if I do print sock, it might do something else because it's gonna grab this right here. And you can do that by testing pointer sock, okay, like that. So let me show you an example. Print sock, tab over, tab, right, tab over, pointer. Let me see how this looks for you guys. I'm curious myself, so we're gonna do this real quick. It needs to be printf. See, that's the difference. You know, I just fucked up. Y'all saw me do it. I wrote a print statement instead of printf, which is a print statement, just different. And see, stock code is an integer, so yeah, I can't just use that because it's an integer. So let's see, integer right there. Boom. Call it code character, but argument two has type integer. Yeah, I can't even print. I don't know why I thought I would be able to print as a fucking. Okay, now we should be able to. Now we should be able to do. Let me see. Let's see that's out. Segmentation fault. Okay. It's normal. HTTP. Okay, what the fuck is it doing? Permission denied. Change the permissions. They probably want me to do this, but this shit's not working. Alright, let's change the permissions. HTTP server. C, change the permissions. Now we run it. HTTP server. Alright, so me trying to show you guys isn't working. Wait, what the fuck? Pin it to the host. Pin it to the host successful. Fort is an integer. You see what I'm saying? Like, the fuck is they talking about fort is an integer? That shit is commented out. Alright, let's get back to the video. If you guys want to experiment that, you could do that yourself. I'm gonna get back to the most important part of this. So, void function, we're creating a sock, passing a parameter which is an integer pointer that will point to, is going to point to sock. It's going to point to the memory address stored in sock every time. It will never, ever, ever do anything else. So if that sock right there, this creation is -1, we do error no. If error no is equal to e access, -1 is error, 0 means successful, anything positive successful, negatives non-successful. Error no is the error message, which is, it's a global variable. So if I look up error no, you're gonna see. Okay, make sure I'm still recording. I just have to, gotta do that now since I'm in here. Error no. Look up error no. Error no holds. Error no is a global, holds all these, and you don't really wanna specify all of these. So the quickest way to do it, honestly, you just do say if error no and then print the error no message. You say if error no, print the message for error no, error. There we go. And then we exit on one, which is exit failure, meaning the socket creation failed, okay? So that's what's happening. And there, which is an if statement, we have an if, nested if, print the error message, handles anything that's unpredictable, we can't predict it. It'll print that, it'll exit, and then if that, if the above statement, if all this right here, well not this, well if this, we say the sock creation doesn't fail, we print sock made. And you're probably like, why do you say sock? Cause I write everything in short term. Fuck, why does it matter? As long as you understand what's going on. in your code, then you could do whatever the fuck you want in your code. You feel me? Structure, basically this is called structure holds, you know, holds things, okay? It's just like a list, holds crucial things that you can use for other sorts, okay? A way to group several related variables into one place, so it groups variables that you can use, okay? So like how you're gonna see here, I'm gonna actually show you beforehand so you're not confused on what I'm talking about. That N, this is the SOC address N, the family. This variable right here is going to store something. This variable right here is going to store something. This variable right here, and this variable right here. So basically, let's get to it. And then to use it, to store it in this, we have to add our own variable to this structure so we can use the structures, which is server. You see, server dot the sim family. Okay, IPv4. We're putting IPv4 in the sim family since sim family is an address family. We're using htons. You want to know what htons is? Htons converts values between host and network byte order. So it converts values to network byte order. Okay, it's that simple. That's all you gotta take from there. Um, go back. Htons are s underscore port 880. It's a macro, like the IPv4 AFN it, but we're specifying it here on our program. Okay, and then send address, S address is the address we want to store in the structure, and to do that we have to turn the string into a network byte order. I believe so. Oh yeah, also you have to keep in mind about these libraries. So what libraries we're using right now is we're using stdio, right, for printf, right? So you do like this, printf function, socket function, what is this? Network byte order function. Yeah, that looks about right. Okay, we could use this too. Error handling. I wrote string 2 times. I didn't even see that. Pardon me. Okay, so in the address, right? That's what we were doing. Let me look that up. In it address. What does this do? In the address converts the string pointing to into standard dot notation. So it turns into a standard dot notation. It turns our string into a standard dot notation to it turns our string, the internet standard dot notation, into an integer variable suited for the use of an internet address. So it's basically just converting our string into an integer variable used for networking. Okay, somehow. What does a networking byte look like? What if you really want to see what it looks like, you can do this. What does a internet value look like? What does the internet value look like? Fuck is this? What does this say? was a suitable, right, suitable internet address look like the bytes. So this is what it's looking like right here. It's turning whatever we use into bits and bytes, and 4 bytes, 32 bits. It's an 8 octet, right? 4 octet. 1, 2, 3, 4. 4 skilled, tired. Uh, little lag switch, little lag switch. Okay, let's move on. So once you create the socket, you want to bin to the socket. The bin method allows you to listen for basically what it does. Allows you to do anything there. Have common connections. Okay, so we create the socket, we bend to it, we go to it. Okay, we stand by the door, we look through the peephole, whatever you want to consider it. You feel me? Okay, so bend to the server. See, we get the size of the server and the structure. We get the size of that, and we put in a variable called sock length, which uses the sock length underscore t function. Uh, it is not a function, by the way. I'm sorry. I keep yawning and things. I'm tired. Let me see the time. What time is it? It's 21:45. It's 9:45. I've actually slept today. I don't know why. I'm tired. But looking at code is draining. So if you understand, you understand. Okay. So we're saying if no, we print ear no, string of ear no. Okay. Exit failure. That's basically what's happening. Bin takes a file descriptor, a sock file descriptor, which we're always pointing to the memory of where the socket creation. Okay, it's going to point to here the socket creation. Simple. It's typecasting the sock address to the server, which we use to grab the memory of anything in the server using the and asterisk, the and symbol, right? I believe so. Let me look it up for you guys. And method and C. Simple. That's how you break down code. That's how you understand code. Anytime you code something, you want to do this at the end of it so you understand what's going on. And before we play, it returns the memory address of that variable. This is kind of used when you're working with pointers or when you're working with a pointer and you want the memory address of that. So pointer, so we created a pointer. They created a pointer here. You can just use the pointer. You just use the pointer which will point to 10. So look, let me, this is how you figure out the difference when you want to ask questions. I'm tweaking. And it sock string 0 and sock. I don't feel like typing this again. I gotta speed up the process for you guys. Okay, so basically, yeah, I just had to figure that out because sock is a pointer here. Points to the memory of the socket creation. This points to our server, which grabs all the variables and the structure. And then we get the socket length, which is the size of that, so we get everything. Error message, if it's equal to that, we're doing this. We're exiting on failure, else bidding was successful. We listen to, we listen for 10 connections only, allowing 10 connections only on on the socket. Let me say that for you guys. Okay, that's the function right there. That function is called sock creation. I broke that down. Now we're doing client communication. Okay, it returns nothing. We're using a void. We have buffer, 64 bits, holds 64 bits, using a variable that uses size of size t for unsigned integers. So it returns either positive or negative, allows us to handle both. So we use a receive method, which receives something from the buffer. Decide we get the size of the buffer. We allocate. We take. We subtract one space. We subtract one spot of memory from it so we can use it later on. Right? Subtract one. We subtract. We take away one spot of memory, 1 byte from it. Okay, we take away 1 byte from it. Allocate 1 byte of room. Okay, and then if byte tr is greater than 0, we're going to do this. We want to add this no terminator to the buffer of the receiving message. Okay, and we print the receiving message. We have a constant pointer that will never change. We always say welcome to the server, and we send that to the client file descriptor, and then we get the string length of the response, which is right here, and then we send in the response. That's basically it. Handling the HTTP request line. If you don't understand that, you gotta go research that. I'm not gonna break it down, but we have the method, the path, and then the protocol. This is our response that we're gonna send back to them. So we take in the method. So right, they send the response to our buffer. We go to the buffer. We check for the method, the first three, the request, second, the pro, boom. Then we print that out. Okay, and then we send the response right there. This right here. I probably have to use my mouse for you guys so you guys can really see because it's going to be hard to pick up. So we send res and then we get the string length of the res. We send in that to the file descriptor. If OK res is less than 0, failed. Else, successful. Then we close it. Then that's the end of everything. And then we hold everything that isn't needed. Everything important goes in the main function, okay? So this is our pointer function right here. We have a variable that's a pointer, so you know it's a pointer. It's gonna do something. It's gonna grab the memory of somewhere and very important. Okay, we define a structure, sock address in with the client variable. We get the size of the client variable and we store that into the sock length t client length, which we can call. Okay, so sock creation, right? Sock creation. We use this pointer variable. Actually, I don't even think we need this because sockfd, this function is a pointer. Sockfd pointer. So you really gotta think though, cause like right here is not using a pointer. Okay, so I understand what's happening. So we're declaring our variable, and when we pass sockfd into the creation function, that will now in that function the memory of sock will be stored in sockfd, and then we use our pointer to point to that address, which we'll use here, which is accept. We're defining the pointer. We're accepting that socket. We're accepting that connection on the socket. We're pointing to the client, right? Everything in the client, every member in the client, which is sock address and structure, and we get the length of that. So if that is equal to -1, that's the error. If we want to delete this if, what's it called? If error no, failed, print that, close that method, else, connection established, and then we print client FD. And to handle the communication, we gotta pass our client, right? We gotta pass our client function, client communication, pass the variable of us accepting the connections, okay? And then after everything there, it'll move on to here and close that function. Once it exit, close the socket, exit successful. Or we could just do exit 0. So now it's time to show you how it works. GCC, boom, 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 change the mod, boom, boom, boom. You go here. What the fuck? What in the fuck? Okay, go here. You already see. Let's see here. Oh shit. Okay, go here. It's bending. Look, we got this. Okay, now. No, sock made been into this host successful, so it's waiting for a connection. Wait. Okay. It printed 4. I don't know why it printed 4. We can go and examine that. But if we send H, welcome to the server, boom, boom, boom. H sent, but that's not how we want it to actually go. Already in use, host is already in use. So that means we have to close that. Host is already in use, host is already in use. Host is already in use. God damn. Fucking bullshit, eh? Fucking bullshit, eh? It's like, no. Alright. What does it print for? What the fuck is for? Sock made. Been into host successful. Receive message. Welcome to server. That's definitely what the issue is. I'll tell you that. Alright, now it's ready. You ready? That is not the issue. Still printing the 4. Alright, what's in the get method? Welcome to the server. Welcome to the server. That's simple. I wonder, 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 I wonder. This is the last time I'm gonna try. I wonder what happens. What? 480. Unable to connect. We gotta run it. But it's gonna take some time to get the fuck out of here. It's taking mad long. We gotta handle more than one client, because right now it's only handling one client. So if you want to see that in another video, let me know. The next thing I'm probably gonna do is add um more functionality with the client communication, because as you've seen, I can send H and it'll send 200, but I need to send the get before that. Basically, I just have, this is just very basic, as you can see, very basic. Nothing's truly happening. Okay, let's see. What the fuck? What the fuck? What the fuck? Receive message, response sent, and it closed it. That's something new. We gotta figure that out in the next video. Okay, so you've seen it work with this in a terminal. It doesn't work with the browsers though. It closes it right away. So yeah, that's the end of the video. If you want to see more, let me know. It's Wonder. We out. You already know what that means. You see that? What we do, we win and we wonder why. Have a good one.